We all have been studying XYZ coordinates since our school days in our geometry classes. But do we really know it at all? The XYZ coordinates is not just a point in space, but a system that represents it. Before diving into the XYZ coordinates, it is worth knowing what was the question at all to develop this system. The question was to make a globally accepted mathematical language that connects algebra to geometry. Before the invention of the XYZ coordinate system, scientists faced many issues in physics and mathematics, such as representing space, motion, geometric figures, etc. To solve this problem, René Descartes, the French philosopher and mathematician, proposed a paper, La Géométrie, in 1637. He tried to solve geometrical problems algebraically using x coordinates and y coordinates. There is an interesting story. According to some legend, Descartes was inspired to devise his coordinate system by a fly he saw crawling on tiled ceiling. He was lying on a bed and he saw a fly on his ceiling, and he was curious to know what can be the position, how can we calculate the position of this fly. And he decided one way to choose a corner of a ceiling and count the tiles both horizontally and vertically from that corner to the fly. So for example, let's say this one might be the origin, and then his purpose was we can calculate from the x-axis and from the y-axis and we can get the position. And remember one point, he has a reference point. Without this reference point, XYZ coordinates failed. Now let's talk about where XYZ coordinate system is being used. These are being used in a lot of ways. Some might be in 3D games, open world, for example GTA or Minecraft. The second one can be navigation system, GPS. The third one in Robotics Arms. Now we are going to deep dive into in each of these three examples and see how does this coordinate system be applied in all of these three at system level. So in our first video, we decided what is a system and how to think in a system. We discussed about input, internal interactions, output, uncertainty, constraint, and we are going to see how these all three be applied in all of these components. So first of all, the 3D games or open world games. Here open world means I'm talking about GTA or Minecraft. First of all, it uses XYZ coordinates to mainly detect its exact position. Every object exists in space. So what are the inputs? Inputs can be the player movement from the keyboard when you press W or from the game controller, the physics forces, because without physics a game is not interesting at all, the AI movement. Now you have seen a lot of games include AI to automate some tasks like the behavior of the NPC or to change the climate in a lot of ways. Animation update. You might have heard about patch version 9.81, 9.82, 9.9. Those are the version of the animation updates. If we are going to think about the internal interaction, so what can be the internal interactions of 3D games? Example, let me draw a XYZ coordinate, X, Y, Z, and we can get the position system using XYZ coordinates. For example, let's suppose this one is the world of a open world game and this is our player. So how does the engine detect the position of the player? For example, 12, 13, 14, or you might have heard the I, G and K. So in Cartesian, it can be represented as 12I, 13J, 14K. X is left right direction, Y is forward, back, and G is the height. The second internal interaction can be the physics engine getting the velocity dx by dt or dy by dt or dv by dt. We can also calculate the acceleration as d square x by dt square. The collision system. This one is the most important. If you have played an open world game, this is our open world game, and inside we have all of this game, and these are the boundary. So when your character is near the boundary and when he try to go there, he can't, and those are the boundary, and this is where our collision system comes. For example, if player dot x is greater or equal to wall dot x, then just don't let it move. Now let us discuss the third main pillar, its output. So when you press W, when the system calculates its internal interaction, what we expect the game to do? So we expect the game to move the player, which means player movement, the changing of the camera position, because hey, when you just press W and the player keeps moving but the camera is still just showing the same background, it will not be interesting at all. And the third one is the object animation. When you move your character in the game, the object will also change. The fourth can be the background rendering. Just as I said, when you move, the background changes, and so it's animation. Let's now talk about its constraint. So what do you think about the constraint? For example, for a game like GTA 5, the constraint can be its memory limit. Constraint that just prevent the game from playing smooth. It's frame rate, because no one enjoy a game with lower frame rate. The physics stability, because when you try to jump a character from the top of the building, and there should be the gravity that will pull him downward, but if the player is still here in the air just hanging, that contradict the physics. And what does uncertainty includes? We can think uncertainty as something that happen immediately or something that unexpectedly happen. So the uncertainty can be the code field, the electricity, the cloud. For example, Minecraft literally built on XYZ coordinate plane. They have the grid, and let's say this one is Z, this one is Y, this one is X, and as I said earlier, it helps in easy collision detection. Now let's talk about our second example. Let me change the color. The second example was navigation system or GPS, global positioning system. First of all, the GPS was just made for the military, but later it was also made available for civilians daily life. So if we design the earth, if I draw the earth, and let's suppose this one is the center, this one is latitude, this one is longitude, and this one is altitude. So if person is here 2 3 4, then its position can be written as 2i plus 3j plus 4k. One question for all of you. We have heard our earth is neither oval nor circular. So how do they calculate the center of the earth? Search it, read it, write the answer in the comment below. So let's just talk about its input. Its input can be the satellite signal, the time information, the orbital information, the receiver information. And what can be the internal interaction? Let's say signal transmission. Now let's talk about its internal interaction. The internal interaction include the orbital information, the signal transmission, from, let's say this one is the satellite and this is you, so it's in the information via radio signal. And the second can be the time of flight. Time of flight calculation is calculated as the speed of light into time delay. And if you are talking about the output, what can be the output? What we suppose I open the map, so it just took the every information like the satellite signal, time information, orbital information, receiver information, and it takes everything calculated internally. So what would I expect? I would expect the system to show me the latitude, longitude, altitude, the velocity, precise time. These outputs are used in smartphone navigation, aircraft navigation, maritime navigation, mapping system, autonomous vehicle like a flying car, precision agriculture. Let's talk about the constraint. The constraint include signal, line of sight, because for the radio signal to travel from the receivers to the satellite, there should be no any type of disturbance like wind. The sky should be clear. The second one will be receiver hardware. The receiver phone should support the hardwares that transmission of the signal would be smooth. The orbital mechanics. Now what can you think about its uncertainty? We cannot predict happening, but still it happens. So the uncertainty might include the dense forest. When you are inside a dense forest, so it will just, the tree will just block the signal. Indoor environment, for example, you are inside a building, like tall building reflect signal. This is quite interesting to know how does GPS actually knows us. And if you want, I will make a separate video on this topic. Just write in the comment box below. The third one was the robotics arm. If you have seen a robotic arm, let me try to draw a picture. This one is a spring and this one is Y, this one is X, this one is Z. So the robotics arm treat its center as origin. The robotics arm first take the reference as the origin and then it moves in X axis, for example left right, the Y axis forward back direction, Z axis vertical direction. If I try to draw it, this one is yaw, Z axis, this one is pitch, this one is roll. Now you are just moving your head. What is roll? A roll means you are moving your head in such a way that it touches with your both shoulder in both direction. For example, this is your head, this is your shoulder, and you are moving your head in such a way that is try to connect to your shoulder. What is pitch? Pitch means nodding up and down. For example, when you try to agree, you are agreeing with your head, that is pitch. What is yaw? It's like saying no. When something contradicts with your belief, you say no. That is yaw. And these three parts is the most important part in the robot. So let us now talk about its input. The input to the robotic system include the joint angles, the motor command, the sensor feedback, its target position, like for example to move the gripper to 0.2 meter, 0.4 meter, 0.6 meter. What can be the internal interaction? The internal interactions include the forward kinematics and inverse kinematics. These two define the movement of a robot. Example, a robotic arm or robotic hand. If you want the detailed video on this topic, write it in the inside the comment box below and I will make the detailed explanation on these two topics. These two define the movement of a robot. What can be its output? What do you expect robot arm should do? Its output include end effector position, tool orientation, a complete task like grasping, welding or assembly. For example, this one is the robotic arm and this is the object. There is the position of this object as well, 0.2, 0.4, 0.6 in meter, and we'll say hey pick the object which is there at position this one and it will just pick the object. What can be the constraint? Joint angle limit. When I told you it can move to only a certain angle, so that is the constraint. The arm length. When you try to expand it, let's say the arm length could be 0.5 meter and if the object is at 2 meter, it will not work because of its shorter arm length. The payload limit. When you try to say hey robotic arm just pick the car here, it can't pick because the car weight is heavy. You should have to design the robot in such a way that it can pick the car. What can be the uncertainty? Its uncertainty includes error in precision, the sensor noise, mechanical flex, the calibration error, or the actuator inaccuracies. Now, these were the three examples we just discussed in system level. How does these three examples work in system? Now, as we saw, whether it's a robotic arm picking up an object, or a satellite locating your phone, or a game engine rendering a virtual world, many systems begin by representing a space using the same language, coordinate system. But let's talk about where it is failed. The constraint of XYZ coordinates. So it failed when it comes to the circular motion, radial motion, or rotational motion. For example, turbine, orbital motion, rotating machinery. And that is where n-t-z and r-theta-z coordinates appear. And we'll discuss this both equation, and we'll also derive these equations in our upcoming videos. Coordinate system assume a fixed orthogonal frame and linear directions, which works well for many engineering systems but becomes inefficient when motion follows curved or rotational path. Now let's talk about the uncertainty. So what are the uncertainty of XYZ coordinate system? Measurement noise, inaccurate position estimate, numerical precision, reference frame error, calibration error, time error. For example, we saw there in the GPS system, the radio signal takes some time from the satellite to the user's receiver phone. In real engineering systems, XYZ coordinates are not exact values, but they are estimation affected by measurement noise, sensor limitations, model assumptions, and numerical precisions. Now, the Cartesian coordinate system XYZ is one of the most powerful ways engineers describe space. It allows us to represent positions in robotics, navigation system like GPS, and even 3D game worlds like we discussed in our examples. But every model comes with assumptions. Cartesian coordinate assume fixed direction and independent axis. When motion becomes curved, like a car turning on a track or a particle following a path, these coordinates start to hide the geometry of the motion. Engineers solve this by changing the coordinate system itself, like we discussed about r-theta-z or n-t-z coordinate. In the next video, we will explore normal, tangent, z coordinate at system level. This channel is about understanding engineering systems from first principle, learning in public, building under uncertainty. Understanding engineering is not just about solving equations, it's about choosing the right representation of a system. If you like the engineering to think from the first principle to think from the system level, this channel is for you. Stay tuned. Thank you for your time.